Okay, we're going to take notes on series today. A series is related to the sequences that we've been doing. It just is the sum of a series. So we're going to start with some notation. At the top of your page, we're going to draw a rather large picture, so prepare yourselves. We're going to draw a capital sigma, which looks kind of like this. You start and make this little line and that little line, and then you angle in, and you go back, and like this. It may take you a second. It's taking me a lot of practice to make one of these, but that is the Greek letter sigma. And I'm going to write to the side that that's sigma, just so that you'll remember. That's what this symbol is. And sigma in math means sum. So basically what a series is it's a sum of the terms of a sequence. And usually it is a finite number of terms. So we're going to start by talking about all the different pieces of information that are going to be here. So at the bottom, they're going to give you whatever variable they're using. I'm going to use a lowercase I. I like to put a little curl on mine. And it will tell you what term to start with. And we call this the index. And basically it's on this one, if it's 1, it would be start with the first term. If it were a 2, it would be start with the second term, third term. It's going to tell you what part of the sequence that you want to add up. And so on the top of the sigma, they'll have another number. I'm going to put a 6 up here, and that's called the upper limit. And that's going to tell you, for in this case, it would be to stop at the 6th term. So it's telling you, okay, for the sequence that you're going to do, you're going to start with the first term, second term, third term, fourth term, fifth term, sixth term, and you're going to add them all up. And then instead of giving you all the terms, they're going to give you a formula to find the terms. So we're going to give you this formula as just for I. So this is the formula to get the terms. So just to kind of go back over, it's a big sigma. It means we're going to sum up the terms of a sequence. We're starting with the first term, ending with the 6th term, and whatever numbers they give you, that's what you're going to do, and then this is your formula. So we're going to find all of those terms for the sequence and add them up. So what I would do is I would take a little room and I would go, okay, so what's the first term of my sequence? So I'm starting with the first term, which is 1. I'm going to put 1 in for I. 4 times 1 is 4. Then I do the second term. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. And 4 times 6 is 24. So I know that I'm going to stop when I get to 6. So basically we just found the first, second, third, fourth, fifth, and sixth terms for this formula, because it tells us to start with 1 and stop with 6. And then all you do is add them up. I just am going to I used a calculator to do this, and the answer is 84. So that's basically the gist of what this notation means. There are some shortcuts that you can do for some of the specific terms, but for most of what we're going to do, this is just going to be simpler. Sometimes the shortcuts are actually long journeys. Okay, so let's go down and do a couple more examples. I'm going to write these sigmas slightly smaller. Get this lined up. I'm just going to use a couple lines. So I'm going to make my sigma very badly. And I'm going to use a different variable this time. I'm going to start at the bottom and say m is 1. We're going to start with the first term. We're going to go to the 5th term, so I'll put a 5 on the top. And we're going to use the formula m plus 2. So we're going to find 5 terms, first, second, third, fourth, fifth, using this formula and add them up. So for my first term, I'm going to take 1 and put it in here. 1 plus 2 is 3. Then I'm going to put 2 in. 2 plus 2 is 4. And then 3 plus 2 is 5. And then 4 plus 2 is 6. And then 5 plus 2 is 7. So I'm using this formula to get these terms. And then I just add them up. If you use a calculator, add them up or add them in your head, whichever you prefer. You'll get 25. Oh, and by the way, I forgot to tell you, this is called the expanded form. So if you ever see anything like that on a standardized test, it's asking you for the expanded form. This is what they want. If they say to evaluate, that means they actually want the final answer for what that sum is. Okay, so let's do one where we don't start with the first term. Scoot my paper up, do another sigma. I'm going to try to do better this time. Oh, look at that sigma. That's pretty good. We're going to use k this time. They can use whatever variable they want. And we're going to start with the third term. So we're not going to do the first term and the second term. We're going to start with the third term. We're going to go all the way to the 7th term. And our formula to find the terms is k squared. So I always find it a little tricky to keep track of these, but just make sure that this is the first number that you're putting in and you'll be okay. So I'm going to put 3 in and square it. 3 squared is 9. And then I'm going to do 4. 4 squared is 16. 5 squared is 25. 6 squared is 36. And then 7 squared is 49. So this is my 3rd, 4th, 5th, 6th, 7th terms of my sequence. And you go back and use the sequence notation that we had before. This is the 3rd term was A3, A4, A5, A6, A7. This is still using the things that we learned before. This is our explicit formula. They leave off the A in part, but that's what it is. And we're just adding up certain terms. So if I add all of those up, I get 135, and that's it.